Let's see if we can get back to this guy. Okay. Let it get up here. So I would do my rook with the groove side towards Z0, because that's the bottom side of your part. If you do it the other way, you end up with that nice faced off part being on the side you're just going to cut back off. See what I'm saying? So my V side is my side that is Z0, so that I can face that part off. My parted off part is going to be the top of it, because otherwise I end up with a inconsistent bottom on my part, like we have on some of our other ones. There we go. So if you do it like this, you'll be facing off this part. This will be your nice face off part, right? And all you're gonna do is mill it to smithereens, because you're gonna put your grooves and everything in it. This is going to be the side that has the nipple on it, and so it's going to be the side that is a little more inconsistent on the bottom of it. You can leave it like that if you want to.
So
I would flip my Z, yeah. So I would have it sitting like this. I think this is going to be a better part. So we'll go straight to manufacturer, go into our setup. I'm going to go to turning, grab my lathe. Now, one of the things that you want to look for is you want to make sure that when you're doing this setup that you're putting kind of everything in that right spot. So my Z flipped to the right spot. I need to be from the front. And if I want to have some offset in there, I can. But I got to remember that moves my 0 out, okay? So I could have this here, and then still, then that makes the face of this Z0. So in your program, if you move that out, it's not really necessarily changing what you face off. It's really changing where 0 is. So if you're looking at your part print, going, okay, so this is a ½ inch, this is 3/4 of an inch, this is 2 inches, this is 3 inches. Move this back 50 thousandths, this is -50, this is -550, this is -800, this is -3 inches 50. So you just have to keep remembering that. And when you're creating programs for other people, when they're looking at the program going, hey, Desiree, how come the part's 3 inches, but it's going back 3 inches 50 thousandths? You're gonna always have to keep telling them the part's 50 thousandths back. So probably the questions will come up, why is it facing to Z of -50 rather than Z0? So what you want to start to be thinking about now, so if I were to say, okay, everybody write your program, hand it to the person to your right, how are they going to run it without having a lot of problems? So maybe we'll do that today. Maybe we'll just say, everybody, you're not going to run your program, you're going to run somebody else's program. So everybody hand your program to the right. So that's what we'll do today, just so you can sort of feel that. So I know you probably already tweaked your program the way you want, but remember the idea is, so if you're planning on being an engineer, so like Clint, he does not ever run his programs at Honeywell. He always runs somebody else's program. So that means he always has to be anticipating what is it that they are thinking when they are doing something. How are they articulating that to me in a setup sheet or a set of work instructions? Okay, so today we will do everybody give their program to the person on the right, and you will not run your program. So you're running to the person in front of you. You're going. So this is the loop. Okay.
So my program goes in.
No, you get mine done.
Yeah. So then your program goes to you. Your program goes to you. Your program goes to you. Your program all the way across it. Okay. So pressure's on today to make a good program, right? Or maybe it's not. Maybe you're just hoping the person to the right makes a good program and you don't care about what your program's like. But like for me, I want the least amount of questions asked, so I want you to make me a program that works really well. Alright, so that'll be fun. Alright, so I'm gonna make my link just a smidge longer, just cause, not really, anything about that, won't really matter. Is this our fourth part? So we're gonna make this program 400.
What do you get yours for? What do you mean? Like, you know, like PSs or? Yeah, like PSs. Tell me. Don't have the opposite. Yeah.
Gonna have that uneven bottom on there, but yeah, that'd be fine. Huh? It's gonna have a parted off bottom rather than a nice smooth faced off bottom.
So you want a smooth face off bottom?
I would want a smooth faced off bottom for my part, so it's set. Like the ones that you already have that have, think about the way that you part stuff off and how it doesn't look as good.
So like, why would you want that smooth face off bottom if you're gonna like cut it off?
It's the bottom of the part. Like that bottom is the bottom of the part.
Yeah, but we've been facing off the front though.
Right, because that's how it worked best for those parts. So here you have an opportunity to take and make a really nice bottom on your parts without having to do another operation. So like on the other ones, you could come back in, face off the bottoms of them on a manual lathe or another operation, just get it nice and smooth. You could just leave them, you know, just please don't take them to the belt sander. Because I don't know of any of you guys who have ever made a nice part by belt sanding. Belt sanding is like this thing, you're like, this looks terrible. I'm gonna take it to the belt sander, the magic wheel over there, and you're like, it looks worse. I'm still turning it in, you know, and I'm like, oh, so, like, what if you just face that off right there? Nope, go into the belt sander. Or you're like, hey, I forgot to put a chamfer on there. I'm pretty sure that I can hold it and spin it, and no one's ever done that, right? Like every time I've seen, I'm like Ray Charles could see, like blind people everywhere could tell that you belt sanded that on there. They're like, that is the unevenest thing I've ever seen. So anytime that we have the opportunity to do the backside this way, I would want my backside to be faced off, or my bottom side to be faced off, because this is going to end up getting that section counterboard down the top of it. That's how I would do it.
Can you know the second time?
Yeah, good foot.
I love this idea. I'm so glad that I just randomly had the idea of everybody send your part to the right. That was I'm like a genius, man. All right, 1.5" stock, fixed size cylinder. And then I've got, it's gonna be program 400 offset 1, so that's gonna be just 54. Everybody good up to there? Okay. So I'm gonna go ahead and save mine. Seems like a good time to save. So first thing that I wanna do is just come in, face this thing off, select my tool. I'm gonna go to my VNMT 431 that I've been using, and so if I leave it as is, I've got a surface finish of 600. We've been doing about 1,000 on surface finish or surface speed. I want to max my spindle at 1,200 just so I don't get that really quick high RPM, and Desiree saw that the other day when she parted something off, and you guys might have heard bing, 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 going in there. So make sure that when you wanna watch for that max spindle speed. I probably will go ahead and, since this is really my face cut, I'll go ahead and just put it down to 6,000s on there. I'll leave the lead in and lead out, okay? They don't bother me. Model front, I'm happy there. I'll go ahead and bring this down to stock OD, and I will maybe go 100 thousandths. Stock OD, I'll go 100 thousandths. And probably can leave the rest of that alone. Move my tolerance up to 1 thousandths. Compensations in the computer. Fourth tab. I think everything is okay. Full retract. I like the way that it's coming in. I really don't necessarily care if this is coming in or out at a 45, especially for this, it's not going to matter. Okay, so I've got a nice face off. Now I need to do some turning. Same tool.
So when it shows it like that, do you need to flip your X in your setup?
What do you mean? How it shows my X being up?
How it shows your cutter being from the top.
Well, I mean, I can just, I mean, if I want it from the bottom.
Okay.
So, I mean, ultimately, I guess really, that's what it's going to look like. But I, you know what I mean? If you're standing in front of the machine, because it's going in like that. But so I just want it, I don't really care if it's coming from the top or the bottom, I just want to see it come into it, yeah.
The way it highlights the part, like how yours turns all blue, mine doesn't do the whole thing.
It does not face the entire thing?
Because they didn't read out the sections in the top,
Yeah.
the low cut sections.
Yeah, on these, it is way better to create a turning model and then add the other things into it, because you've already got the notches in the rook, as I was, and so it's stopping there. So it's seeing those sections and going, we got something different happening here. So I would delete those things out. I would just do, I think in the video, all I did was make the turning section of it. It's gonna be way simpler to go in and delete those, go back to your design and just delete those out, or stop now, do this save as, turning only, delete out those chunks out of it. Chance, today, what should you go buy?
What should I go?
An alarm clock. 20 minutes late. Do you need us to wait for you to get yours?
Anything beyond that point, so all those
All you're focused on right now is everything that just gets turned, no milling features in there at all. You can definitely turn the entire thing, having the entire thing drawn, but as of right now, it will be easier if you have just a turning model, and we'll add the other stuff in as it goes. Now, if I was doing this on a live tool machine, that had 5-axis lathe or something, I would have the part flipped, and I would grab all the milling from the other side, and then I'd part it off. The bottoms of the part. I put some small radiuses along my V groove and some other areas just for deburring purposes. I just wanna have some nice edges on there, so 20 thousandths at the bottom, 10 thousandths at the top. Those are not really on the print, those were just parts that I had added into. How you looking, Cal?
I was still showing the same thing.
Did you delete all that stuff out? Okay, bring it over here and we'll take a look at it. It's going to be better if you will work off of what the video that I did, and that's gonna keep you from having this, where everybody has to stop and wait. Why is Z so far back? You deleted all the milling off of it? They're still milling. Alright, let's go. Okay.
It's the axis on it.
Dang it. Wish it wouldn't have done it like that.
You're doing it all over.
Yeah, so we can try to put those other ones back in and see if it'll take those. But you're missing. See how that looks? See how that looks? It's not the same. Did you watch the video of it?
I was going by the video.
No way. Couldn't have been, because I don't, no, the video that I made, that I put out there for just the turning section. Yeah, cause I changed, so what I was telling you guys last week, to do your radiuses like this will potentially cause you problems later on. And this angle, we changed some of these things on there. You're gonna start over. It's pretty far away from what we've got. Okay, so our turning profile, we should be able to leave this alone. We'll max our spindle speed at 1200. I'm gonna go back up to 12 thousandths per rev. Over here. So if I want to go back further, I can, but it does cause me a little bit of problems if I do that, because you start to get that undercut that just goes back further. So like normally I would turn back an additional 1/8 of an inch. I'll show you when we get to that point. We'll look at that and see why that causes us a problem. 0.1 and stock OD in 0.1 and leave that. I'm gonna leave a little bit of stock.
So which one are you doing right now? Are you finishing?
I am roughing. So here's what I don't love about this is when you go back that additional 1/8 of an inch, it really wants to dive down into the part because you've told it to allow radial grooving. So anytime that it can go beyond the part and start to clear some areas out, it's going to try to do that. And that is fine. It's not going to hurt us here. If we don't want that in there, we can go back into here and then just change how far back we want to go. So maybe -10. That'll change how far back. So you just get that little bitty groove back there.
For my finishing, I don't think it's liking the lead out.
Okay, so what's it saying?
Lead out has been modified due to a gouge with the remaining stock.
Okay, so it does it's just a yellow, it's a yellow triangle, right?
Yeah.
So yellow triangle is kind of like a yield. It's just telling you what it's done is you've left yours to where you did maybe a lead out or lead in at 45 degrees. And when it's coming across there, it knows that it's going to clip that part. It's gonna clip it as it does like the last operation, as it retracts at 45 degrees, it's gonna smack it. So what it's saying is, hey, we've changed that, so it's gonna come up and miss that. So it's saying, you did not have it right, I'm going to adjust it for you, so you don't run into your part. Because if you say, I don't want it to do that, probably back here, or here, probably more like here, it's going to gouge into your part as it's doing this operation. So those are beneficial things. If you want to have those things off, so it doesn't, if you're a person who does not want a yellow triangle on there, you need to go in and change. You can change your lead out to probably 90 degrees or 0 degrees, which. Yeah, you turn your lead in or lead out. I think, yeah, we did. We turned your lead in and lead out off, I think, the other day. And so then it's going to go, when it has lead in and lead out turned off, it's just always going to go this way. It's always going to go perpendicular to the part. Then you're never going to have to worry about it. Lead in and lead out is beneficial because it follows the contour more. And so if you have a really complex setup or a part that doesn't leave you a lot of extra room, it will make sense to have on there. All right, finish pass is same tool. Change my feed rate down to, let's go 6 on there. I want my spindle max at 1200. No, actually that could be 0. Everything else I'm probably pretty happy with. Okay, got my finish pass there, and so I've got this same yellow triangle, and I am happy that it modified that for me. But if I don't want that, then I can just go in and turn those off, and so now I no longer have them. Do you turn yours off, or do you modify yours? Okay. Okay. So if you are a triangle warning, if that bothers you, like it's an issue, then because it's kind of like a service engine light, right? Like you either need to fix it or you need to put a piece of electrical tape over it. And so you know, because the light bulb will not burn out, you know, as much as you hope. You can unplug it. You can definitely do that. You can smash the LED, take a paint marker, and go over. But you got to do something with it, or you got to be like me. I just get used to it. I'm like, oh, I just assume that's that's how I know the car's on, you know, because the service light's on.
For the finishing, or
What's that for the incomplete
are
sentence?
you gonna do a grooving cycle for that little?
For this?
Yeah.
We already did it. Yeah, it's in the profile, and since it fits within the 90 degrees, which will fit within our tool profile, it's going to just grab it as it does it. So as it does finish pass, it's going to grab that groove, and then it's going to take it along as it goes, which is really helpful by doing that all in one tool, because then we can come in and we have no stops, which helps to keep it burrs. Were you going to ask a question?
Yeah, how come you didn't put a 250, or maybe it's not 250, but there's a radius, more to the left of that part, like,
Down here.
yeah, you didn't do that?
Because when I drew it in the YouTube video, we took that out. We changed that.
Oh, okay.
Yeah.
I didn't see that.
Yeah, so not only is that part changed, but the angle has changed. So,
What is the,
I don't know off the top of my head.
So I can change the angle.
It's gonna help with some of our tools, as we
Should
go.
probably go back and change it then.
Yeah, I would.
Okay.
And so then part off, come in, change tools, and go to my grooving parting tool. I want to make sure that I've got the right one on there. and that is 125 wide. Enter. I'm going to make that's tool 4. I want to make sure that my spindle does not go up super high. Go ahead and change these things. If I want to leave extra stock there, I can. I don't.
Are we doing edge break too?
I think I probably would.
Even with the radius in the front,
What's that?
even with the 10,000 radius.
You know, I usually will put something in there. If anything, it just helps to keep any kind of burr from there. But yeah, I mean, you do have this radius on the back side, so essentially you should not have anything there. So I would do, if I was going to do an edge break back there, it's probably, you could do a fillet, and I'd probably do it, I think we were 10, I'd probably just do 10 back there, just to make sure that that one goes on there nice and clean. Okay, I want to make sure that I do pecking, and I want my peck depth at maybe 50 thousandths, my retract is 10. I want to use a reduced speed and feed. This right here is radial. So that means at 200 thousandths, it's going to reduce down to 1. I need to back up. I did something wrong. On my max spindle speed, or on my surface speed, I want to be 300, not higher than that. That will be a slow part off, but it will be a better part.
And what'd you put for reduced speed and everything? Is it 1?
And so at 200 thousandths diameter, it'll start to slow everything down. I could probably go down to about 150. If I go any smaller than that, it's going to wobble when it changes. So I don't really want to go down much further than that. Make sure I got save. Okay.
Can you simulate yours?
Yeah. Let's go from the top and simulation and
Mine has a little bit.
are you leaving stock? Did you leave 10 thousandths on the OD? If you didn't leave 10 thousandths on the OD, it may not see or know what stock you have there.
I have stock to leave on.
You have stock to leave on?
No, I don't.
So what it's doing is, between rough pass and finish pass, it's just going back over what you did. So you want to make sure, I left 10 thousandths stock on radial.
Okay, leave 10 thousandths on the roughing.
Yes, on the roughing.
So my stock to leave says X and Z. Doesn't say.
So it just X.
I guess I already had it.
Everybody else's looks good. You are comfortable with handing it to the next person.
The turning part looks good.
Huh?
The turning part looks good.
Yeah. And that's all we're concerned about right now. So milling is going to be several different operations, and like I don't know if you remember us talking Thursday about construction holes. We need to start when we start to do our other parts, we need to be doing, a 3-axis operation that puts some construction holes in the back of our parts. Remember we talked about dowel pin? Yeah, dowel pin's construction hole. So I've got, dowel pins, I think I saw the box out there, got some dowel pins that came in, so what we'll do is we'll dowel our jaws, and then we'll just, all we have to do is put a hole in the bottoms of our parts. So on some of the, like the Rook is one, the bottom of our part will have a dowel pin hole in it, so a 255 hole that goes in about 150 thousandths, and that's just gonna help orientation so that we can go from here to here, and they always fall in the same spot, because otherwise, grooves around the outside versus the turret part of the Rook, they would not be necessarily in line. They might, like, you might try to line them up, but they wouldn't necessarily be straight in line. So since we're gonna go 3-axis, so we go 2-axis lathe to 3-axis mill, to 3-axis mill again, to 4-axis, to get our grooves in there. We want all of those things to stay in the same orientation, so that's why we'll have to have some construction holes. Mikhail, are you caught up, or are you considerably behind? Okay, so, we'll take Mikhail out of the loop, we'll just rotate, yes.
Take me out too.
Okay,
I didn't know there was a YouTube video that you did separate.
Yeah. You're out of the loop too?
Yeah.
This took me like
I
10
didn't know
minutes to
this
draw
video.
before class, and I got it.
That's what I
all
was
done.
gonna say, like, I did the entire video in 15 minutes, like,
Well, I watched.
All I did
start
was look
to
at the last
finish.
print, and I had it
Yeah.
drawn.
yeah, so. Almost everything that we will do, unless I say, hey, there's no video for this, then we'll try to have a video for it.
Jay, are you watching the video?
If you,
Just look at the last print. and-
yeah, if you subscribe to the YouTube channel, then it'll just tell you, hey, the Rook is out there, ready to go, okay? So it will be helpful to you. So how about we do this? The next two, I will not do a video for. I'll just throw the drawings out there, and then I'll throw a modified drawing out there of what the Titan thing should look like, of what, so there's the original Titan. You gotta stop doing it the way that the Titan guys are doing it, otherwise you're going to have radius problems, because they're throwing radiuses on. I'm not saying they're doing it wrong, but they're doing it wrong for what we're doing, and they're putting them in the wrong order. If you do it in the 2-axis drawing, everything flows. It's a lot easier to do it like that. I'm not saying that they're doing it wrong, I'm just saying this way is better, and it's just smoother. It's smoother this way to do that. Okay, just run your own part. This is not gonna work. Okay, next two parts that you're going to do, that you're not gonna have videos for, I will put drawings out today that will be for the king and the queen. You're running somebody else's part. So that means tomorrow when you come in, we're going to work on the king and the queen. I will give you drawings for them. You will be running someone else's program, okay? So think about that as you're writing the programs. So both the king and the queen, for the turning sections of them, you're gonna be running somebody else's program, okay? All right, let's go to it.